Welcome learners once again to the NPTEL module on handling large scale unit level data with Stata. We are at the verge of explaining the unit level data and its backgrounds. So, now we are actually discussing in the first week, though we have discussed all available unit level data in India. Now, we are actually discussing or approaching towards using Stata though in the next week, but we are now approaching through understanding the sampling design, because if you do not know sampling it is completely incorrect to start with Stata. So, therefore, our this week week number 2 is actually designed in such a manner that you can easily understand sampling techniques correctly. Because for a researcher or for a PhD scholar especially or even policymaker, it is very important to minimize the sample error. Sample error always I mean reduction in the sample error or less the sample error always gives better results for interpretation. So, therefore, we are reviewing the sampling techniques. In the last lecture particularly, I took you to the discussion on types of sampling. Especially I have already started with the discussion of probability sampling. In the probability sampling we have discussed simple random sampling, then we also discussed stratified sampling, systematic sampling, and also we try to understand what is called cluster sampling. So, these 4 techniques we have covered already. Now, some little parts of the probability sampling is still left, which is highly utilized in the NSS survey or even other large scale survey data. So, that is none other than multi-stage sampling. Okay. So, these days multi-stage sampling is very important, and let me start with the multi-stage sampling without delay further, because this is going to be very useful. Now, first point in the multi-stage sampling is let me first give you the general understanding of multi-stage sampling. This is the word is very clear. This is where we are clarifying through the stages of sampling. So, stages of sampling, like it might include randomness, it might include stratified stage, it might include systematic routes, it might include cluster phase. There are, I mean, if you club all the different tools of sampling in one umbrella, then generally these are called multi-stage sampling, but there are certain structure a systematic structure of understanding multi-stage sampling. So, let me go through point by point and explaining the concept very clearly to you. Now, sampling procedures carries out in several stages using random sampling technique. When the sampling frame is rarely available, or if such a list is available, it might be too large usually to overcome such a problem, because if it is too large in handling or proceeding through the sampling, it might be very expensive. So, since it is too large, it is always suggested to go for multi-stage sampling procedure, and these are often employed in the present age. Each point of sampling is called stage. The term multi-stage sampling procedure is generally used to refer a sample selection process that has at least 2 stages, minimum of 2 stages. Any of the probability sampling techniques may be used at each stage of multi-stage sampling, as I already discussed from the beginning. Now, one such example of multi-stage sampling employed by NSS, National Sample Survey, is through different labels, label 3, 2 and 1. So, label 3, where I have already discussed, usually the sample size is less, label 2 it is little higher, label 3 is label 2 is it is higher, and label 1 is even much higher. Now, what do you mean by label 3? Suppose we wanted to, I mean especially in the NSS, we wanted to observe their sampling frame correctly. So, in the label 3 they stick to the area, I mean they divide the area by rural or urban. Okay. So, it's actually not just a random, it's not at all a random, it is called a stratified format. So, label 3 may be referred as stratified. Then for the at the desegregated level they considered the household. Okay. In the label 2 it is further desegregated. Now, you can find out, I mean, number of units here for our understanding, it is higher in the label 2 as compared to label 3. Label 3 the number of sample is lesser because number of rural areas and urban areas are relatively lesser as compared to the households. So, in the label 2 we are referring to the households, where in the label 3 then further desegregated level is in this context is individual. So, the individuals, now here we are considering different possibilities, okay, and the number of individuals are expected to be higher because the sample in the population itself the total number of individual is higher. So, the sample size accordingly also increases. So, therefore, label 3, label 2 and 1 identifies different forms of or different stages of sampling. Now, it depends upon which exact sampling techniques is adopted. Maybe at the label 3rd we adopted stratified. On the second on the another tier of the sampling frame we might have adopted again on stratified technique. On the final one we may adopt any form depending upon the context, we will explain in our succeeding slides. Let us move to the understanding of a new technique which has been adopted recently by NSS and earlier used in other like ISDS data set called even the NFHS has already adopted probability proportional to size sampling. Okay. This is also called probability proportional to population. Okay. In the place of size NSS considered as population, it is called PPP. Now, what is the rationale behind considering probability proportional to size? First of all, this is adopted to minimize the number of sample or minimize the expenditure on sampling, and there are proper reasoning based to reduce the sample size based on certain proportional indicators, probability proportional indicators. Now, let me go through the points correctly. If there are more than one subpopulation with varying size of entities each, PPS sampling ensures that the probability of an entity being selected as a sample is proportional to the size of its subpopulation. So, a particular unit or entity has certain probabilities of consideration is actually proportional to the size of its subpopulation. So, we will explain now, though it is not so clear, we will explain systematically to clarify the concept. So, this is also sometimes considered as an alternative to stratification, because just stratification may not consider proportional representation. So, the steps involved in the probability proportional to size sampling includes list of all clusters. So, clusters may be villages or sector or ward, the way we have just discussed before, and population of each cluster is written against or corresponding to that of the clusters. So, let us consider one Excel sheet. In the Excel sheet we can enter the details carefully. Now, this is serial number 1, we can write down serial number 1, 2, 3, 4 and so on, and we can make like the cluster of the villages, let it be villages, cluster number villages, and what you do, we have to write down the population of the villages. If our cluster is defined as village, then let us write down its population. Where to get the population? From the census. Census latest, it is always suggested to go by the latest census 2011, those who are doing some research in this regard. So, we will let it be this is N1, this is N2, likewise this N3, likewise this, if this population is there. Then on the third column we will follow a cumulative population CP. In the cumulative population, so this will be N1 plus N1, so this is N1 plus N2, this is N1 plus N2 plus N3, so on. The cumulative population should be calculated. These are some steps to be followed. It is very helpful steps to be followed to select a particular sample with a probability stick structure. Now, how to do it? Then what we will do? We have to let me first go by the points. We have to define a sampling interval. What do you mean by sampling interval? So, once we derived the cumulative population, we will get the total n, capital N here, and n divided by, now n divided by the number of clusters you require. How many clusters you define? These are not clusters. Initially we define the villages by their population, and these are the real figures collected from the census data. Now, on the last column we will figure out which sample to be selected based on the cluster. Suppose we want to divide the entire population into 10 clusters. Okay, so divided by 10. So, each cluster how many population is actually defined. So, basically this is n divided by 10. Now, choose the random number between 1 and sample interval. So, first suggestion here, the next step is to choose any number between 1 to n upon 10, if 10 is the sample interval. Okay. So, after selecting this, how to select that random number? It might be a random start, or you may take the help of any tools, computer through the computer random table. Random tables are available, or from the Google random number chart, it will suggest a number, any number, or any number you simply pick off, okay, called random number start. Now, that is also called random start. The first cluster to be sampled contains this cumulative population. Whatever is coming out of the total population, suppose let me mention in the table itself, suppose it is of some value out of the total population, you have got a particular figure, and find out in which particular serial number it falls. Okay. Suppose it falls in serial number 2, not in 1. So, that is your starting point. Okay. That is your first starting point of selection. So, okay. So, let me mention then that is the first starting point, maybe within the serial number 2. So, then what you will do, how to find out the exact sample? The sample would be your random sample selected from the beginning, that is first sample you have collected, then you simply add random sample, that is let it be within the serial number 2, you have figured one particular number, okay, and that particular number corresponding to N2. Within that N2, a particular household is selected. Okay, if your household is your unit of survey, or if now here it is village is your unit of survey. So, the N2 is selected. Now, N2 plus your sample interval, if you add it, that will correspond to another serial number. Let it be another serial number falls maybe in 3, not in 2, now it in 3. So, now that one will be selected. Okay. Now, again you will add 2 times RS plus 2 times sample interval, RS plus 3 times sample interval, and you will keep on doing till d minus 1. D stands for your actually the number of that is d nothing but n by 10. N by 10 we have already divided, n divided by 10 is basically your d. Alright. So, number of clusters, basically the d is nothing but number of clusters. Okay. So, number of clusters times the sample interval, if you make it, that will be actually the units are selected for your work. This is 1, this is second unit covered, the third unit covered, and so on, and accordingly number of samples will be collected. So, basically what we followed here in this method, we have followed, first of all we have followed a systematic addition of the population or cumulative population, and we divide it into different clusters. Why we divide into cluster? We wanted to make it random, as if each cluster has equal chance of selection. So, now randomness is attached, cluster approach is attached, and we also followed a systematic approach, systematic sampling design. So, this method includes three important aspects. One is your clusters design, then randomization, then third one is systematic approach, because you keep on adding the sample interval to the first unit selected or to the second unit selected. So, three methods simultaneously included in case of probability proportionate to size sampling. Now, for example, as considered in periodic labor force data of 2017-18, the urban first stage unit we have already discussed earlier, that is UFS blocks were selected by the probability proportional to size scheme with replacement. Why with replacement is discussed? There are two approaches. One is called without replacement or with replacement. Since randomness is there, I have already said they have made a randomization. In the random sample case, there are two approaches. One is called with replacement or without replacement. Without replacement. So, in with replacement, basically what is going to happen? In the with replacement case, your n remains same. Total n, suppose number of clusters are 10 and number of clusters you are supposed to select 10. Now, with replacement, suppose one cluster is selected, how many are left? 9, only 9. So, 10 minus 1 is left. Now, if you are following a with replacement technique, your 10 is still left. So, your probability of selection remain constant, whereas in case of with replacement, your total n becomes n minus 1, again in the next time it will be n minus 2. Okay. So, the probabilities are not same. So, basically in the probability proportionate to size sampling, with replacement is used in the periodic labor force data, that is of 2017 and 18. And with replacements, because of that, they followed urban first stage units with a probability proportional to size scheme with replacement size, being the number of households in UFS blocks. So, size we have already said, number of population, basically they considered as the size. Sample for a panel within each stratum were drawn in the form of two independent subsamples. To implement the rotational schemes, 4 subgroups again, 4 subgroups of samples of FSUs of equal size they have followed, and were drawn randomly. They have divided into 4 subgroups and they have drawn it randomly. Similarly, in case of rural areas, subsamples are also defined, and again they followed with a replacement, probability proportional size with replacement scheme, and size being the population of the village, and equal number of samples were allocated among the 4 quarters. Because why 4 quarters are said? 4 quarters actually the periodic labor force followed 4 quarters, and 4 quarters, as I have already mentioned, in the rural areas the portions are different. Portions are different in successive quarters, whereas in case of urban areas the same portions are actually repeated in the successive quarters. So, accordingly they followed the sampling frame. Now, what about non-probability sampling? We already covered probability sampling. Now, let us move to the understanding of non-probability sampling. So, non-probability, the word itself clarifies the meaning, that is the probability of selection of the particular unit in the sample are not same or is not same. So, non-probability or the non-random sample are not truly representative therefore to the population. So, therefore, this is less desirable than the probability sampling. Those who want to make a policy design for a larger population, you have developed certain ideas, certain outcome from your experiment, but the experiment may not be actually representative. to a larger group. So, therefore, your sampling method you have adopted may not be representing a larger group. So, may not be actually feasible for policy if it is targeted for universalization approach. But if it is targeted for a particular cohort or for a particular subsection, your experiment is meant for a subsection, then it is not problematic and it is perfectly fit. So, usually let me give you the background of publication these days. The editorial or the editors of different topmost journals usually expect your result must be representative enough. Except few, there are some certain experiments made and experiment is very expensive. So, some experiment may not be actually representative because that is targeted for a particular group. But it is observed from many papers, many journals that they expect as if your result is representative and it calls for many policy implementations. So, therefore, our attempt every time, even if it is non-probability structure, the sampling frame is of non-probability type, but there are some techniques to make it more generalizable. Okay. So, let us go through further. So, this method is used in cases where researcher may not be able to obtain a random or stratified sample. It may be too expensive. Actually, usually what happens, if you want to generalize every time, it is also expensive. You have to consider more sample size to generalize. So, but in this case a particular group is tested, particular behavior is tested, particular cases are tested. So, therefore, we need not require large sample size, and moreover this is more qualitative. Okay. And so, the validity of the non-probability samples can be increased by trying to approximate random selection, as I just said couple of minutes back, and also by eliminating as many sources of bias as possible. Now, non-probability samples requires also time, also it requires cost, it has very limited objective as I said, and we need to understand the feasibility of studying. Just experiment is not enough, just behavioral mapping is not enough. Okay. For example, recently we go by the cases, health related cases due to coronavirus. It is declared by the WHO as pandemic. Okay. Pandemic is usually declared when it is a special case usually occur in once in 100 years. Okay. So, since it is pandemic, so cases are expected to be very specific. Okay. So, people are now put in different detention center, and they are being tested. Even if the common public are not affected with the virus, but they are being tested, they are being captive. So, and it has been reported in different newspaper that these people are under huge stress, and there are also some cases where people are leaving the detention camp without intimating, they are actually trying to escape from the detention camp. There are many reasons, but now point here is important to discuss, because suppose one researcher wanted to understand the stress level of the people, those who have come across this kind of experiment, then now it is not generalizable, because all are not infected, all are not having the same probability, they are not random. So, the particular cases must have been tested, those who have already faced these stages. Okay. So far is the present days that random samples are taken to understand the stage 3 of the coronavirus. So, stage 3 may be generalizable, because they are considering the mass infection case, whether a common public is affected due to another person or not. So, in that case random may be fine, but so far as the stress is concerned for the particular person, you have to go by the particular person study and you need to observe carefully. Okay. So, let me proceed. I have already given you the recent very recent example. Let me go by certain other methods of non-probability sampling. One is called convenient sampling. So, attempts are made attempts to obtain a sample of convenient elements. Often respondents are selected because they happen to be in the right place at the right time. sometimes known as grab or opportunity sampling or accidental or haphazard sampling, and a sample is drawn on the basis of opportunity use or basically we use who is available, that is also called convenient sampling. Usually you might have seen researchers consider the sample conveniently from their own area, from their own proximity, okay. That is also one form of convenient sampling. So, here the example is very clearly, the picture clearly clarifies what is called convenient. The researcher wherever located, maybe the nearest distance is the sampling frame, okay. Then some other may not be included. Now, so far as purposive sampling is concerned, it is selected purposively by the researcher and is based on the intent of the research and depends on the judgment of the investigators, and the investigator exercises their judgment in the choice and includes those where the judgment is perfectly fit, okay, judgment of the researcher actually perfectly fit. This is also called judgment sampling, and the researcher attempts to obtain the sample that appears to him to be very representative of the population. It is basically related to the researcher. So, here the picture is very indicative, and the person researcher is located here, and the researcher understood very correctly that these people are, some people are going to be representative enough in capturing the reality, then that is I mean those are selected for the sample. For example, if the researcher wants to analyze the drinking habits of students from a particular class, let it be there are students of 100 in size, that particular researcher wanted to select 25 students as sample. So, in his opinion in the class, those who are representative in his opinion, they are actually selected. What about quota sampling? The quota sampling is another form of non-probability sampling. Some particular quota as specified by the interviewer is important. Quota may be based on based on representative of the data. For example, the researcher wanted to understand socio-economic status, education, gender related information, demography, particular feature like health indicators. So, then the researcher may divide the entire population into different groups. So, different groups like different subgroups are defined. The subgroups may be actually may be divided on the basis of the purpose, okay. So, I mean based on the quota, like quota, if socio-economic indicator certain percentage is required, the researcher is going to take that off clearly, and accordingly some percentage are actually included. So, now what about snowball sampling? Snowball sampling is the sampling design followed as part of the non-probability sampling, where some forms of referrals are considered, like it is since many of the research or survey requires huge cost, we can get many information through our reference. Likewise, look at a case of a candidate being selected for a post. For example, in IIT pattern or even in universities, faculties are recruited. In the form they call for references, okay, letter of recommendations, LOR, and LOR actually forms one base of actually referring whether the candidate is perfectly fine or not. So, I mean actually testing through another references. Now, what we will do, basically what we consider another person for our selection to be selecting another third person. Whether the third person is good or bad, the first person is going to report to you. So, similarly, if you want to increase the number of size, this our first person might say that those person if you select would be good for our for our institutions, okay. So, the design is clearly identifying the snowball sampling, like this. Here is the researcher, now is the first person now referring to the three persons. In our example, maybe 2 person, maybe more than that. Now we are suggesting the three maybe a reviewer to suggest another couple of information from your own network, okay. For example, now even in the recent case also some state government has already followed. In the recent case of coronavirus, some state government actually are trying to tap the people from the villages, those who have some connection with international boundaries, like they are asking to the panchayats and through the Anganwadi worker that you collect the households, those who have those families are having some connection with the international world, and those used to travel. So now they selectively consider those people. Okay, so how it is possible? Now we selected some particular points. Now those have the responsibility to select more numbers. Okay, so accordingly a better sampling design is captured. So these are all associated aspects we have already discussed. So accordingly we can discuss other aspects, like once we have completed probability and non-probability sampling, we have the responsibility here also to discuss errors in the sampling design. So errors are very important to minimize the sampling, to get a better sampling design. So sampling errors are important. So what we will do, we will discuss the sampling error and its associated factors which can define a better sample size in our next class. Okay, so our next class will be sample size determination with understanding sampling error. So these are we are going to discuss in the next class. I am keeping these slides for the next class. Okay, so with this let me stop here. Thank you.